In this video, I'm going to walk you through the materials prep for lesson 5 of Unit 8.1. Okay, we've got a pretty big hands-on investigation in this lesson. And so you will see there's two investigations. One is called the spring scale investigation. This is pretty simple. You're just going to provide a 5 Newton push-pull spring and a 10 Newton push-pull spring for each group. And they're going to push on the spring scales and find out that no matter which one you press, the force is going to register the same on both scales. So this is a pretty quick investigation. And so you just need to have the spring scales available for the groups. The next investigation is a peak force collision investigation. This one takes a little bit more prep. You actually need to prep the carts with the spring scales. There is a handout right here on how to do this. And so you will remove the S-hooks and you're going to put the tracks on your lab stations. You need to tape them down, but go through this resource to set up your cart systems. Half the class is going to measure how mass affects the force on the objects, and the other half is going to collect data on the speed. So a slower speed and a faster speed. The goal of this is to find out that mass and speed both affect the amount of force. It makes it a greater force. However, the forces are still the same in opposite directions. And so it's that science idea that we're developing here, that each object applies a force in equal and opposite directions. And so you will have half of your lab stations ready for mass with extra washers. It says to have some modeling clay, and I think that's mostly because you are going to need to stick the washers or just to make sure things don't fall out. I would say if you have extra spring scales, have some prepared for your day one spring scale investigation, and then have another set attached to your cart so you don't have to modify the spring scales between in the future. There's also a video right here. This you will play for students to help them understand how to use the twist tie. Now, this is in the directions for the spring scale and cart modification setup. You'll see there's a little twist tie that's on there, and it starts all the way close to the edge. If I start over, you see it starts all the way close to the edge of the plunger. And then once it rolls towards and hits that brick, let me go back one more time. You'll see that the spring scale, as it moves, the twist tie moves with it. And so where that twist tie ends up is the peak force. That's the highest force that was applied to that plunger. Now, there is a little bit of trick with these twist ties. It cannot be too tight or it will not move, and it cannot be too loose because then it won't stay where it needs to stay. And if the kids touch the cart, the twist tie can move. So you might want to, when you're talking about the setup, talk about letting the cart just stop and don't touch it, and try to read where the marker is, or like how much it went in on those marks that you have drawn on the plunger. Now, some people have learned that making those marks on the plunger are quite tedious. And so what you can also do is just carefully have students push in the plunger up to the twist tie, and then you can use the markings on the actual plunger to read the amount of newtons that can registers for the amount of force. I hope that makes sense. Anyways, so that's all about the investigations. There are a few handouts. Let me go to the top. You can see here, this is comparing forces on two push-pull spring scales. This is where students will make predictions, and they will be comparing when they push one and not the other, that the forces are the same. So we're starting to develop that idea there. This is investigation 1's handout. And then investigation 2's handout, we're actually planning together. So we have that independent, dependent, and constant or control variables handout that we reuse from lesson to lesson. And then students are going to create their own data table. What they really need to do is make sure they have like a low mass and a high mass, a low speed and a high speed. So you might want to guide them towards that. You can also create a data table and put it on the handout for them to complete. There is a reading. This is actually bringing in that life science standards that's kind of sprinkled throughout the OpenSci curriculum. This is talking about touch sensors. And so it's suggested to do it as a home reading or homework, although I'm not personally a big fan of homework because it doesn't get done. But I would say this is important because you're going to hit this life science standards in several different units when we're talking about how the brain registers your sense receptors. And so this one is touch. Let me scroll down. I've added a few things here. You can just do this on the board or a DocCam. This is the investigation questions that students will write on their handout. The first one is for how changing speed affects the forces on the objects. This one's how changing mass affects the forces. And so half the class will put one investigation question on their handout. The other half will write the other one. The last thing is there's a pretty large consensus discussion in here with a very large model. However, if you prep for it, it's not as hard. This is your starting poster that you will use for all classes when you begin the discussion. So you're going to draw this on. It suggests 2 chart papers. It's up to you. You can also do this under a DocCam. But what it's suggesting you do is you're going to incrementally add to this poster. And so I've added some directions here. I've also kind of talked about the ideas that you're going to add one at a time incrementally. And then I just took them from the teacher guide below. Here are the steps. So in number 1, we're going to add deformation. This is these drawings should already be there. You're going to add this yellow text. In part 2, you're going to add peak force on subsystem A, which is this right here. And then the third one, you're going to add peak force on subsystem B. And then you're going to add the larger peak forces. Now, the key here is that are your arrows, that you have a larger arrow representing a larger force. And we just figured this out in the investigation. And it's also important that your arrows are the same size. And then really highlight this. You've got a stronger peak force on A equals a stronger peak force on B, and they are still equal. That's the key, equal and opposite forces. All right, good luck. Kind of a lot of prep. Enjoy lesson 5.